Lonely integer. There are n integers in an array A. All but one integer occur in pairs. So we have n elements in our array, and this array is called A, and all the elements are duplicated. Your task is to find the number that occurs only one. So only one element doesn't have a duplicate inside an array, and we have to find which element it is. And the input format is the following. The first line of the input contains an integer n. Standard, first they give us the number of elements, and then the next line contains n space separated integers that form the array A. So then on the second line we have the whole array. Usually they were giving us n lines, each with one element of an array, and this time they are giving us on a single line, and they are simply separated by spaces. And in case of numbers, it doesn't matter. We can simply separate them by spaces. But if there were strings there, it could be problematic. Then we couldn't have strings with spaces because otherwise it wouldn't be possible to read it. And here we have constraints. So n is between 1 and 100. So it's a very small array. And n modulo 2 gives 1. So n is an odd number. I think it makes sense because otherwise we couldn't have the conditions of the task, because either we would have to have all elements repeated, or some more than one element would have to be without a pair. If the number was not an odd number, if the number of elements was even. And all elements are between 0 and 100, so there are no elements smaller than 0, and there are no elements greater than 100. Pretty straightforward, and here we have some examples. So if the number of elements is 1, we have only a single element in the array, then this element is our lonely integer, and in this case it is 1. If the number is 3, then we should have one pair and one lonely integer, and here we have 1, 1. This is our pair. 1 is duplicated, and 2 is the number that we are looking for, so our answer is 2. And in case of 5, we would have 2 pairs, and in this case it is 0, 0. It's our first pair, and then 1, 2, 1. So 1 is also duplicated, and we are looking for 2. And as with everything in Bash and in programming in general, we can take a number of approaches. And the one that I want to show you right now is with involving dictionaries, because dictionaries can be used to solve this problem, but they're also pretty interesting structure inside Bash and programming in general. So I think it would be useful to do it this way, because besides learning something new, it's also really portable to other programming languages, and I think that's something that's also pretty fundamental. That's what everyone should know. So we would take the dictionary approach, and I will explain you first what are dictionaries, and then we will come to the task itself. So let's open a script, and let's try to create a dictionary. We can create a dictionary using declare, and then minus flag with big A. It stands for those dictionary arrays, and then the name of the dictionary. And we can create it on the same line as we declare it, or we can create it one line below. Let's do it like this, then maybe it's a little bit more readable. And as with normal arrays, I said normal, but dictionaries are also normal, but the arrays that we know, we use parentheses to declare the elements. But then, here is the first difference, we have to specify the keys, and keys play similar role to indices in normal arrays, and you will see how it works. So for now we use square brackets for the keys, like square brackets for indices in arrays, and keys could be strings. There could be numbers, but there could be strings as well. So for example, under key A, I can hide number 5. And under key V, I can put number 10. And now I can display my dictionary. using similar syntax to arrays, except for exclamation mark, and now dict as with arrays, and we use the square brackets with @ to access all elements. And let's see how it works. Let's save this script, and we are getting B and A. So those are our keys. And how can we get the values? So in arrays, we've got indices, and those indices were ordered. Those were integers starting from 0, then 1, 2, and so on. And with dictionaries, we have much more flexibility. We could put strings, numbers as keys, and they don't have to follow any order. So we can choose whatever we like, and those are the keys. So that's how we can find the elements, and under the keys we have to put some value similar to arrays. So they are much more flexible than arrays in this sense, but arrays also have their place. But for the thing that we want to do in this task, dictionaries will be much better choice, and you will see why. So first things first, how to access the element. We can do it in a similar way. So for key A, we are getting value dict A. Okay. And let's just copy and paste this 9 3 times and see how it works. So here we get B and C. So for A we should get 5, for B we should get 10, and for C we will see what happens. For key that wasn't specified inside, and it's simply an empty value. So if you try to use a key that wasn't in the dictionary before, you are not getting any errors, exceptions, and so on like you would in some other languages. It's simply an empty value. So or you can use any key you want. If it's not already there, you are getting an empty value in return. So that's how you can access the elements, and you can of course change the elements later. So if I would try to change what's under 8, I can do it in the same way. I'm accessing the dictionary on key A, and I can put here, let's say, -5. It's updatable. So it works in a similar way to an array. It's still a collection of elements. The only thing that's really different are those keys, at least in the basics. So there are more differences, but we don't care about them right now. And let me clear this thing. And now let us go to the task itself. And maybe before we go to the task, or maybe we can already do the task and introduce the theory on the spot. So what did I want to say? I wanted to say that dictionaries are really useful to create histograms. So we could, for example, what are histograms? Maybe that's the good starting starting point. And histograms are used to count elements. So if we have an array and we want to create a histogram of an array, we could iterate through each element of an array and then check if this element is already counted by our histogram. If so, then we are increasing the counter for the specific element by 1. So at the beginning, all the elements get initial value 0, or in the case of Bash, empty values, empty strings, and or even not empty strings, empty values. And whenever we are iterating through an array, we find an element, we can increase simply its counter by 1. So in the case of this task, each element in the end, when we create such histogram for that array, each element should either have a value of 2 or a value of 1 in its counter. And that's how we can solve this task. So if we create a histogram for the array, we would simply find out how many for each element, what's its frequency inside an array, how many times it occurs, and it should occur either 2 or 1. And then we can iterate through the whole dictionary and find this single lonely integer that's occurring only once, and that would be our answer. So how can we do it? We can maybe first create an array here, like this, and we can copy that example array, and let's put it here. And now we can create a dictionary. So we are declaring it declare -8. And by the way, declare works also with normal variables and arrays, but you don't have to use it. You can simply initialize the variable directly. But in the case of dictionaries, you have to do it like this. I don't know why, or if there is some way to go around it, but that's the thing that was working for me till now, so I am using it like this. So declare minus a hist. Hist, it would be right now the name of our not our array, of our dictionary. And now we can go through each element of an array. So for lm in array, do, and now we want to access our histogram on a position of given element. And what do we want to put it? We want to put there, now I'm using arithmetic operations, that's why I'm doing this double parentheses, and this hist of lm, whatever was there, +1. We found a new occurrence. Then, and now we want to iterate through keys of our histogram. So similarly to iterating through an array, except for this exclamation mark, do echo let's access the value itself and maybe the key as well. Sorry, it's not lm, it's key. And I could put a colon here to separate those two. Done. So what should we have here? If it works correctly, if I didn't make any mistakes in typing or in syntax, we should create an histogram here that should tell us how often it found each element inside an array. And then we should display this histogram that we created on those 3 lines above. Let's just play. For 2 we are getting 1, for 1 we are getting 2, and from 0 we are getting 2. Does it match our understanding? I think yes. So it works almost correctly, except that here we are not creating the array ourselves. They are giving us the array, so we have to use read to access it, and we know that we can read it using -a flag. That's how we are reading an array. So that's the way we can get the user input, or in this case, we can try to test our program against the test cases that they prepared on Hackerrank. And on the first line, they're also giving us the integer n that we don't need at all, but we have to read it as well. And to read with -a flag takes care of the array, and it by default it expects an array separated by spaces, so we don't have to do anything. It would already put the elements in their proper places inside the array. So let's run the code and see if it works. And of course we are getting a wrong number because wrong answer because we didn't put the if statement. Yeah, we don't want to display this echo for everything. We want to use an if. If the value is equal to 1, then we want to display it. And for if we are finishing with 5. And we want to break as well. I think it wouldn't change anything, but if we already found it, we can break as well. So let's see if it works right now. And everything is perfect. Everything is green. Let's submit the code. And that's it for this test. So we've learned something about dictionaries.